Case study: FortifySec's journey, harnessing AI to revolutionize cybersecurity defenses. The financial services company FortifySec found itself at a crossroads. Faced with increasing cybersecurity threats, the organization knew it needed a more sophisticated approach to safeguarding its assets and data. Its leadership, represented by CEO Maria Williams, CTO David Chen, and CISO Laura Evans, were aware that traditional security measures were no longer sufficient. They decided to explore integrating artificial intelligence into their cybersecurity framework. David initiated the project by assembling a team of data scientists and cybersecurity specialists. Their first step was to implement machine learning algorithms aimed at anomaly detection. FortifySec's current system relied heavily on static measures such as predefined rules and signatures, which had become increasingly ineffective against rapidly evolving cyber threats. The team, led by Dr. Emily Roberts, opted for a supervised learning algorithm trained on historical data of network behavior to recognize patterns of malicious activities. As the project progressed, questions emerged. Could the ML system effectively differentiate between benign anomalies and actual threats? Dr. Roberts and her team conducted extensive testing with historical data. They found that the ML system was able to identify deviations in real time, providing early warnings for potential threats. This proactive approach caught anomalies that traditional methods missed, leading to the timely mitigation of threats. The team decided to go further by integrating deep learning techniques, particularly convolutional neural networks and recurrent neural networks. These models had already been successful in image and speech recognition tasks, but could they be effectively repurposed for cybersecurity applications? The team trained a CNN on datasets containing features extracted from various software, both benign and malicious. The results were promising. The DL model achieved a high accuracy rate in detecting malware based on subtle characteristics within executable files. FortifySec's next challenge was to develop an adaptive cybersecurity system using reinforcement learning. Unlike ML, RL models learn optimal actions through trial and error in a dynamic environment. Questioning the feasibility of this approach, Laura Evans proposed simulating various attack scenarios to train the RL models. The RL-based intrusion detection system learned to identify and respond to intrusions by interacting with a simulated network environment. Through repeated iterations, the system honed its capabilities, becoming adept at identifying and countering sophisticated attack strategies. Natural language processing was identified as another critical component. Could NLP enhance the team's ability to analyze and interpret vast amounts of textual data, such as phishing emails and threat intelligence reports? The team implemented sentiment analysis tools to scrutinize social media for signs of coordinated cyber attacks. By processing large volumes of text data, NLP models provided valuable insights and early warnings, enabling FortifySec to anticipate and prepare for potential threats. Maria Williams, always forward-thinking, suggested exploring offensive AI techniques to simulate cyber attacks. This would provide a safe environment to test and improve defensive strategies. Generative adversarial networks were selected for this purpose. Could GANs generate realistic simulations of cyber attacks to stress-test FortifySec's defenses? The cybersecurity team trained a GAN to produce synthetic attack data mimicking various types of cyber threats. This allowed FortifySec to test their defenses against a wide range of potential threats, significantly increasing the resilience of their systems. Despite these advancements, the team faced several challenges. One major concern was the potential for adversarial attacks, where malicious actors might manipulate AI models to bypass security measures. Could FortifySec's AI models withstand such manipulations? Dr. Roberts initiated a project to develop robust AI models capable of detecting and countering adversarial perturbations in input data. This involved refining the algorithms to identify and ignore subtle changes introduced to deceive the system. Data privacy and security were other pressing issues. The AI models required large volumes of data for training, some of which included sensitive and personal information. How could FortifySec ensure data privacy while allowing AI models to learn effectively? The team explored techniques like differential privacy and federated learning. These methods enabled the AI models to learn from data distributed across multiple locations without compromising individual privacy. The complexity and opacity of AI models, especially deep learning networks, posed another challenge. How could FortifySec ensure the interpretability and transparency of these models? Researchers worked on developing explainable AI techniques, providing insights into the decision-making processes of AI models. This enhanced transparency and reliability, fostering greater trust in AI-driven cybersecurity systems. The effectiveness of these AI models in cybersecurity was evident. According to reports, organizations heavily reliant on AI technologies had a higher detection rate of breach attempts and reduced time taken to identify and contain breaches. The initial skepticism within FortifySec's leadership transformed into confidence as the AI-driven cybersecurity framework significantly improved their defense mechanisms. However, could the team maintain and continuously improve these systems in the face of evolving threats? To address this, FortifySec established a dedicated AI and cybersecurity research unit, focusing on continuous learning and adaptation to emerging threats. This unit worked closely with external experts and institutions to stay ahead of the curve, ensuring that their systems remained robust and effective. In conclusion, FortifySec's journey demonstrates the transformative potential of integrating AI into cybersecurity. By leveraging ML, DL, RL, NLP, and GANs, they developed a comprehensive and adaptive cybersecurity framework. The challenges encountered, such as adversarial attacks, data privacy, and model interpretability, were systematically addressed through robust solutions and continuous improvement. This case study highlights the critical importance of adopting AI-driven approaches to stay ahead of cyber threats in an ever-evolving digital landscape. FortifySec's approach provides a valuable blueprint for other organizations aiming to bolster their cybersecurity measures through AI integration.